One of you kind souls informed me that the potassium-argon test that Steve Austin did with Mount St. Helens, where he took a rock from Mount St. Helens and took it to the laboratory and had them test it for age. And instead of it being like 10 years old, it turned out to be really, really old, like, something like 300,000 to 2 million years old or something like that. And Steve Austin's point was that this is proof that, your dating methods are off and the world is older than it, or test older than it actually appears to be. But anyway, I had heard that had been refuted. So I decided to check this out. And I got online and I found this morsel of a website called No Answers in Genesis. I think that is probably supposed to be a absolute response to Answers in Genesis. And it was by Kevin R. Hinkey, PhD. And I believe that is in geology, the way this paper reads. And so I wanted to go over a few things with you in this scientific paper that I think you were going to find fascinating. And in the backdrop of it is, I know that there are some Christians out there that believe that the earth is old. But the reason that I am attacking and going after evolution is because a lot of atheists rest their opinion on the world not having any true meaning or purpose because of the truth of evolution. If evolution is true, then the Bible is probably false, and so I don't have to, worry with God. So anyway, so this is about the potassium-argon dating method dispute. And this is Kevin R. Hinkey's response to Dr. Steve Austin. So, because radiometric dating utterly refutes the biblical interpretations, young Earth creationists are desperate to undermine the reality of these methods. As part of their efforts, young Earth creationist Dr. Steve Austin and his associates at the Institute for Creation Research collected a dacite sample from Mount St. Helens, Washington, USA, which probably erupted in 1986 AD. I think it's really interesting that he uses AD here. I recommend that, but it's funny how scientists can't even keep up with each other. Talking about the BCE and CE, before Christ era and Christ era. So Austin then ineffectively separated the sample into several mineral and glass fractions. I want you to hold that in your mind until the end of this paper. He says he ineffectively separated the sample into several mineral and glass fractions, submitted the dacite and its fractions for potassium-argon 40 for potassium-argon dating, and subsequently used the bogus results to inappropriately attack the potassium-argon method. Austin's conclusions on this project are summarized at the ICR website. Hold on to your horses. Considering the half-life of potassium-40, that it is fairly long, 1,250 million years, the potassium-argon method cannot be used to date samples that are much younger than 6,000 years old. Now, I just have a question at this point, and maybe some geologists can jump on here and really straighten this out for us. But if we don't know our starting points, how do we come up with our ending points? It says nothing under 6,000 years can really be calibrated. So if the years are the actual measurement that we want to go back, but we can't really go below 6,000 years, how are we even getting the first 6,000 year measurement? I know there are problems with scale. So for instance, if you wanted to say how much does the continent of America weigh, that's massive. You got to go, how deep is the mantle? Are you counting anything under the mantle? Are you counting for the elements that are strode everywhere? And then whose data on this are you collecting, and who gets to do the estimates? And you got to be open for a wide error of margin. I know that there's some things that are too large to grasp accurately, But that just kind of gets me into calibration. How are the years calibrated? Like if we're certain it's 4.5 million years and we're certain it's 4.6 million years, then how do we get that certainty when early on we can't even define what the years are? It just seems a little dubious. But that's not my argument with this paper. It's just a question. A few thousand years, and this is back to Kevin Hincke's paper or his website, a few thousand years are not enough time for 40 argon to accumulate in a sample at a high enough concentration to be detected and quantified. This gets me back to the previous. If we can't go under 6,000 years, but the argon is there, how do we know we started at the appropriate range and whatnot? Furthermore, many geochronology laboratories do not have the expensive state-of-the-art equipment to accurately measure argon in samples that are only a few million years old. Well, this is getting interesting. It's not just anything under 6,000 years old. There's a whole bunch of laboratories out there that can't do anything under 2 million years old. Now, I'm supposing there are some laboratories that are more refined. You know, they have, as we're going to see, more precise equipment, and there might be dating for age while somebody else is maybe dating for content. So maybe there's some allowance there. But what's really interesting to me is that very first line. A few thousand years are not enough time for the 40 argon to accumulate. We haven't been doing science for a few thousand years. So how do we know there's any argon accumulation going on? That really confuses me. Like I'm a man of precision on some things, and I want my logic points to be squared off. And it's like, how do we know this? How is that fact just factual? And also notice that some labs have this precision equipment and some labs don't. And both are dating things? What do you think about that? And that gets included in the feedback. Just hold on to that. Labs operating, producing dates without precision instruments, and this is known. Specifically, the laboratory personnel that performed the potassium argon dating for Austin, specifically personnel at Geochronology Laboratories of Cambridge, Massachusetts, USA, performed the potassium argon dating for Austin. This laboratory no longer performs potassium argon dating. I bet not. It was embarrassing to them. A creationist sent a rock in and they went to check it and they sent back a million zeros. And he's like, oh, this is from Mount St. Helens. That's not what I was expecting. I'm sure they don't offer that anymore. But I have something for you. However, when they did do this test, their website clearly stated in a footnote that their equipment could not accurately date rocks that are younger than about 2 million years old. I want you to hold on to that. You know, we don't really know how to measure rocks that are younger than that, with potassium argon, at least. But you shouldn't send us rocks that are under 2 million years old, because we don't have precision equipment. Don't have precision equipment. That's the implication here. Cannot accurately measure this. So what Kevin Hincke has said previous to this is that there are some things that can measure down to 6,000 years, but there's a lot of laboratories out there that can't quite go under 2 million years. Well, I went to the Geochron website, and Geochron is actually still in operation, and they offer a lot of other tests, but yeah, they don't use the potassium argon test anymore. Now, I wonder if that's because they were embarrassed or because it has been outdated, or I'm not quite sure, but they're not offering anymore. But I want you to hear this statement of confidence from the website. Geochron Laboratories has been providing high-quality isotopic isotopic analysis to geological and the archaeological community for more than 30 years. That takes us back to the test, because this is where Steve Austin did his test at. Established in 1960 in Cambridge, Massachusetts, Geochronology was the first laboratory to provide both potassium-argon age determinations and stable isotope ratio analysis on a commercial basis. Now, it is possible that the lab was set up with inferior dating instruments. I get that, because this is for commercial analysis. I get it. I understand that. What's really interesting, though, is our analytical services also include radiocarbon age determinations as well as other radiometric analysis. And we remain a world leader in these and all our services. They're a world leader in these services. So I wonder if the equipment they had back then when they did this test for Steve Austin wasn't top of the line and premier. I don't have enough information to go there, but they boldly proclaim in these other areas, we remain a world leader in these. Remain, that means they are and they have been for a stretch of time. This still isn't my argument. Now here's where I'm getting into our argument of why this is all pretty much bogus. We cannot analyze samples expected to be younger than 2 million years. This is from the Geochronology, website that Kevin Hincke had researched. We cannot analyze samples expected to be younger than 2 million years. How is someone supposed to, and this is me, how is somebody supposed to actually know how old their rock is if the lab won't tell them? So if I go pick up a rock and I bring it to the lab and I'm asking the lab, you tell me how old the rock is. Like, well, we can't properly date any rock that's younger than 2 million years. I don't know how old the rock is. I want you to tell me, but we can't date it unless you tell me if it's younger than 2 million years. Now, I understand the Mount St. Helens scenario because we know when it blew its top, the lava poured down, it cooled and it became rock. We do know that that's younger rock. However, if we went to another volcano that was never recorded in history as blowing its top, we don't know exactly what year it blew or when it happened, etc. How would we know the age? Oh, we saw this one. We observed it. That's how we know it's younger than 2 million. But if I go to any other volcano that I didn't observe and I don't have any records on, how do I know if it's older or younger than 2 million years? With less advanced equipment, memory effects can be a problem with young samples. This is back to Kevin Hincke explaining maybe possibly what happened. That is, very tiny amounts of argon contaminants from previous analysis may remain with the equipment, which precludes accurate dates for very young samples. For older samples, which contain more 40 argon, the contamination is diluted and has insignificant effects. Well, that sounds really great, but here's the part I want you to really focus on, okay, is that there is contamination. Like you put previous samples in there, and then there's this bleed over, there's carryover. This is often the case with scientific instruments. I run across this in my studies on a regular basis, is that these instruments, when we get into very fine-tuned things, sometimes the instruments can interfere with the calibrations, which kind of gets me into how do we calibrate again? But again, well, I'm not going to repeat it. One critic, and this is on Kevin Hincke's site, and here is the statement that he is about to respond to. He said, one critic said that Dr. Austin should not have sent young samples to the dating laboratory because it potentially puts large error bars on the data. By this reasoning, the method could not be used on any rocks, since if we did not see the rocks form, how could we know whether they were young? I think that's a very valid statement. I mean, that seems very, scientific. Did I see it or did I not see it? Here is Kevin Hinkey's response. This is the old, young Earth creationist, only eyewitnesses can provide accurate history scam. Obviously, Swenson, like many young Earth creationists, failed to realize that scientists can successfully unravel past events without witnessing them. Except that they can't with rocks younger than 2 million years. And how do you know if the rock was younger than 2 million years or older than 2 million years? But he says they can successfully unravel past events. Forensic scientists frequently send criminals to prison with eyewitness testimony. Without eyewitness testimony. To be exact, recent hideous actions of the Washington, D.C. area snipers illustrate how unreliable eyewitnesses can be and how important forensic science is in solving crimes and stopping killers. I understand his point. I get it. So with forensic science, if you're a criminal and you cut yourself at the scene of a crime while you were killing somebody and they found your blood there, your blood and your DNA is the only kind that looks like it looks, that tests like it tests, etc. It is a fingerprint. That's more science too. It's an exact match. Exact. It's not off by like 6,000 years or like 2 million years. It's exact. And so in those cases, eyewitness testimony isn't needed because we have something precise and exact. But what about when something's not precise and you're asking for the testimony of whether it's younger than 2 million years or not? That seems kind of conflicting. Here's another example of twistedness in the logic. In contrast to Austin's juvenile attacks on potassium-argon dating, geochronologists confirm the reality of radiometric dates by using multiple methods. That's smart. Let's cross-check against multiple methods. I would probably begin to really believe and follow after these things if it was just that, because if a method can cross-check another method and it's pure science, great. But it says, and or comparing their results with fossil, paleomagnetic, or astronomical data. What? This is constant circular reasoning, as we bring up very often. He's like, it's dumb to question our radiometric dating. I mean, we cross-check it with fossils and paleomagnetism. I've looked into paleomagnetism. Some of that it seems very hokey to me, and it's got some variations that make absolutely no sense. Fossils, they date those by the layer they're in a lot of times. I don't know what he's talking about with the astronomical data, but I think it's very interesting here. He's like, geochronologists confirm the reality of radiometric dates, blah, 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 and or comparing their results with fossil and paleomagnetic and astronomical data. That helps you to understand that the potassium-argon method by itself isn't strong enough to render the dates, or you wouldn't be doing all this other kind of cross-checking. I'll give you one more, it's even better. He lists a string of papers. All of these, and I'm adding the part, all of these, which refutes the nonsensical young Earth creationist claims that radiometric and fossil dating is based on circular reasoning. To be exact, this is gold. To be exact, even without any radiometric dates, stratigraphic, fossil, and or paleomagnetic data usually give geologists at least a rough idea of the age of their samples. I just want to throw these papers on the ground and go on. What? They're talking about circular reasoning. But to be exact, even without radiometric dates, we've got stratigraphic and fossil and paleomagnetic data. yeah, I don't need the potassium argon method to tell me how old this rock is. I got this rock out of that layer. That's how old it is. Using science, there are at least 3 hypotheses that may be purposed to explain why Austin obtained dates of 340,000 to 2.8 million years from his samples. I think it's really funny is that why Austin obtained these dates. Austin didn't obtain those dates. The laboratory obtained those dates for Austin, but I love how he's trying to shift the blame away, and he does that in extended fashion in this paper, but I'm not going to cover it all. But he says there are 3 realistic hypotheses of what happened. I totally agree with the first one. Argon gas, excess argon, was incorporated into the glass and minerals in the dacite as they formed in the parent melt. The argon failed to degas from the minerals before the dacite solidified. That makes sense to me. As the volcano is erupting and pouring this lava out, whatever the process is, it builds up with argon gas. Right, instantly, fast. Maybe like all lava melts did. He says, or there's another hypothesis, number 2. Because all but one of the dates in the above table are below the 2 million year lower dating limit established by Geochronology laboratories, the dates may be nothing more than contamination artifacts of the mass spectrometer at Geochronology laboratories. Contamination. The 2.8 million year old date also may have largely been entirely the resulted from contamination. If the Geochronology mass spectrometer, this is the third option, was exceptionally clean on that day that Austin's samples were run, the dates may be approximately accurate. Even if the absolute values of the dates are highly erroneous, the relative order of the fractions dates from oldest to youngest may be roughly correct. That is, the various minerals, the phenocryst, in the dacite may have grown in the parent melt at different times, and the entire crystallization process may have taken as much as a few million years. Additionally, somewhat older xenoliths and xenocryst from the surrounding rocks may have been incorporated into the melt as it rose to the Earth's surface. So he said maybe just got some older rock in it as it went to the top. Maybe, I just go back to, even if the absolute values of the dates are highly erroneous, well, the absolute dates, so you're blending these dates together? I think they call it whole rock dates. Austin strongly argues that steps were taken in his laboratory to protect the samples from contamination and that the xenoliths were removed from the sample before the analysis. I bet he did, because this was a setup. There was a creationist, Dr. Steve Austin, who got some rocks from the lava. I don't know if it was an intentional setup or it was just testing the theory, okay? But he sends it in, and he was very careful to eliminate these things, and that's what he claims. Fantastic. He also claims that microscopes were used to scan for foreign particles. Now, here's what gets this is where everything gets a little more interesting. Of course, he and his assistants may have missed many of the xenocryst if they were small. He said they might have missed all of these things that are helping misdate everything. They might have missed it. I want you to think about this. He was trained at Penn State to do these things, and he says it's very hard. Although Steve Austin and Swenson will not admit it, some of the grains in Figure 4 may be xenocryst rather than phenocryst. In some cases, the magma may not be hot enough to melt or entirely dissolve the xenocryst, and they may survive after the melt cools. Even the best mineralogist and petrologist, for even the best mineralogist and petrologist, xenocryst may be difficult to distinguish from phenocryst. do you think? Okay, so now we've got contamination on the mass spectrometer. We also have, it doesn't matter if you're a world-class scientist or not, you might mess up xenochrist and phenochrist, and we're getting precise dates of years. But are eyewitnesses reliable? Like here, we got scientists that can't even tell the difference between the two types. So how do we know what kind of tests to run? Here's a part that I think is telling. It's a little more telling. This is Ken Hincke stating this on his website, No Answers in Genesis. I've attempted to separate very fine-grained minerals from glass in coal ashes by using magnetic separation and hydrofluoric and other acids. It's not easy. If you'll notice, that's not really a cohesive sentence. It starts with, I've attempted, and then it ends with, it's not easy. So either this is a Freudian slip or it's the truth, but either way, it's damning. He says, I've attempted. So he is stating himself that he can't get certain things separated, but yet he's blaming other people for contamination issues, as if this isn't known to be. But what if it's the truth? What if it's all samples are contaminated? He says, real scientists, Kevin Hincke, real scientists are expected to provide natural and reasonable hypotheses for their results. Natural and reasonable. Whether their results were anticipated or not. Now here's the kind of the catch with this for me is not everything is natural and reasonable. And I haven't thought about this far enough or deeply enough yet, but there's a lot of men out there that claim that women are natural but not reasonable. People are natural, but they don't always do things reasonable. There's a whole lot of things in science and in life around us that seems oxymoronic or counterintuitive. And so what should we have an eye out for? If we're supposed to come up with a reasonable explanation, is it forced to be natural? What if the reasonable explanation takes you away from modern science? So for instance, if we have no real precision in the older dates, and then we have the quick forming process of lava that can really make dates look old quickly, maybe there is a reasonable explanation for that, whether someone wants to include it in their naturalistic mindset or not. We must be open to the truth, not biased. Real science can be eye-opening.